Alright guys, this is page 1 of the 5.1 of 5.5 review guide. So the first question here asks us to change the quadratic functions that are written in factored form and determine the standard form by expanding. So effectively you're looking to end up in a situation where you are in an ax squared plus bx plus c. That is our standard form. You want to multiply this stuff out here. So you're going to be using that FOIL method for a lot of these. This very first question here, negative 5 multiplied by x plus 4 quantity squared. It's very important to take care of the squared first. So this guy here is equal to negative 5, x plus 4 multiplied by x plus 4. Please be very careful to actually FOIL this out and don't go be telling me that this is x squared plus 16 because it's not. Very common mistake there. Let me fix this camera really quick because it keeps zooming in and out. It's very annoying. Hopefully it is set now, not zooming in and out like that. Yeah, looks good. Okay, so foiling this guy out, if you do it, I'm skipping a little bit of work here. I'm just going to go ahead and use my x squared. And I have a little trick. Whenever you do this, you're going to be adding the 4 and the 4 together to get 8x. Multiplying the 4 and the 4 together to get 16. Again, if you want to do the whole foiling out, that's totally cool too. You're not quite done yet though. You got to distribute this negative 5 to all three. So your final answer here is f of x is equal to negative 5x squared. Negative 5 times 8 is negative 40. X, negative 5 times 16 is negative 80. And all done. Continuing on, this one you're actually going to have to FOIL all the way out because my trick will not work when you have a number in front of any of these. So we actually have to just do all the work here. X times 8x is 8x squared. X multiplied by negative 7 is negative 7x. 3 multiplied by 8x is 24x. 3 multiplied by negative 7 is negative 21. Multiplying this out is done. Now we just have to add like terms. Our final answer, g of x, is 8x squared plus 17x minus 21. Continuing on, we have another squared situation right here. Again, make sure you actually write that all the way out. X minus 4 multiplied by x minus 4. Don't forget this plus 9 is still there. Same exact idea as that previous question. You FOIL it out, you'll get this right here. And don't forget to finalize your answer by adding like terms. X squared minus 8x plus 25. Over here, we have a special situation. We have two of the same exact numbers multiplied. This is our difference of two squares, kind of just going backwards. So here we'll have a negative 0.5x, and then I'm sorry about that. Negative 0.5 multiplied by x squared minus 25. And again, the reason why this is the difference of two squares. It factors into the positive and negative version. Got negative 0.5 x squared plus 12.5. If you were to multiply that one out, you can use a calculator if you'd like to. Continuing on here, doing this axis of symmetry, I did teach this in two different ways. I kind of gave you a formula method if you'd like to. I kind of don't like the formula method. I'm going to use the factoring method and finding the zeros and just doing some extra stuff here as extra practice. So step one, if I'm going to go ahead and factor this, I got to do the negative out of all of them. Then I need to ask myself what multiplies to 16 and adds to 8. In this case, it's going to be positive 4 and a positive 4 for both of them. Now, if you want to find the axis of symmetry, it's going to be smack dab in between both of the zeros. In this case, both of the zeros are actually the same number. In this case, you're trying to make this equal to 0, which means that x plus 4 has to be 0, or x plus 4 has to be 0, or in other words, these are both x equals negative 4. Because both the zeros are the same, the middle of those zeros is negative 4. And when you plug in negative 4, you get 0. So this is our axis of symmetry. And furthermore, negative 4 comma 0 is the vertex. And is the vertex a minimum or a maximum for this function? Because of this negative sign, we're going to have a frowny face parabola. Because we have a frowny face parabola, this guy is going to be a maximum. It's the very top. This guy out here is actually the easiest of all, this 4x squared. All we have to do for this 4x squared is to go ahead and say, 0 equals 4x squared. Hopefully it's obvious that x equals 0. And if this is 0 and x equals 0, that's going to be the coordinate 0, 0. And here is our axis of symmetry and our vertex. Is this a maximum or a minimum? Well, again, this is going to be a happy face parabola because there's a positive in front, and therefore a minimum. Doing the same stuff over and over. This one right here, I'm going to go ahead and solve it both ways. I'm going to go ahead and do my regular method of solving for the vertex as well as the formula method for those who like it. Figure out what multiplies to 27 and adds to 12. If you do that work, it ends up being positive 9 and positive 3. Doing a little bit of work there, that means that the zeros of this function, if you were to set this equal to 0, you don't really need to write this step, but I like writing it anyways. So therefore, x plus 9 equals 0, and x plus 3 equals 0, and x equals negative 9, and x equals negative 3. Truth be told, if you're able to, you can just go right away from here and just say negative 9 and negative 3. That's not a problem. I think that's actually how I would do it. The vertex must be exactly in between these two. Because it must be exactly in between these two, we're going to do negative 9 plus negative 3 and divide that by 2. Again, that is the average of those two numbers. You're always going to be dividing by 2 because you're finding the middle. Negative 9 plus 3 is negative 12. Divided by 2 is negative 6. This right here is our axis of symmetry. Before I move on, I want to show this can be done in another way. The axis of symmetry is always given by that x is equivalent to negative b divided by 2a. When I'm talking about that is I'm using the same exact formula I used way up here. ax squared plus bx plus c. So in this question, a is equal to 1, and b is equal to 12, and c is equal to 27. So if we want to just plug it right in, we got negative 12 divided by 2 times 1, and that will also give me negative 6. Two different ways to arrive at the same exact answer. This way might be easier, but it does require you to memorize a formula. Regardless, once you get to this step, figuring out what the vertex is requires you to plug negative 6 back into the function. That is to say, we are figuring out what f of negative 6 is, and that's going to be negative 6 squared plus 12 times negative 6 plus 27, 36 minus 72 plus 27. And again, feel free to use a calculator. It's not a problem at all. If you do all this work, though, you will end up getting negative 9. And yeah, that means our vertex is the coordinate negative 6, comma negative 9. So I should circle all my answers here. We got this is our axis of symmetry. This guy right here is our vertex. And it is, again, a happy face parabola. Because it's a happy face, this is a minimum. This 15 minus x squared here, a little bit of an obnoxious question, to be honest. Doesn't really have a nice, neat, easy factoring, so we're just going to go ahead and skip this one. I don't feel like doing it. We're moving on to a different question. That ends it for page number 1.